So we're going to start something different than I've done in the past. In the past, I took requests on Twitter and Reddit for video topics and subjects. Going forward, we're going to use videos as a supplement to a new series we have at lockreference.com called Introductory Locksmithing. And that series is going to cover the basics of locksmithing for either new locksmiths, people interested in becoming locksmiths, or people in the lock sport community that just want to learn a little bit more. Certain things lend themselves best to visual demonstration, and certain things lend themselves best to text, specifically measurements and math and stuff like that. So we're going to try to capture the best of both worlds by discussing both and using video supplements with the articles. We're going to start today with this article, which is about key decoding and using various means and methods and tools to decode keys. There's a number of reasons why you'd want to decode a key. Maybe you're servicing a master key system that you didn't put together. Maybe you need to determine a key bitting specification. For example, Corbin and Russ, when they have various key classes and depths and things of that nature. And unless you're familiar with them and working with them routinely, you're probably not going to be able to know which is which when you're decoding a key. I mean, we do a fair number of Corbin Russ one here, and even I still have to check from time to time. So with that said, we're going to go through the methods, and I'm going to show you a few different ways and a few math formulas you can use to help you decode keys for whatever the reason. Throughout this, I'm going to be using terms, number one, that are adherent to the Professional Locksmith Dictionary that the List Council has put together and maintained. And then number two, I'm also going to be referencing key bitting specifications a lot. If you don't know what key bitting specifications are, go to our website, click on Tools. There is a page there for key bitting specifications. It will explain everything I'm discussing and then some. And then it'll also have links to about 20 or 21 different key bitting specifications that we've already compiled into PDFs that you can download, print, distribute, whatever. We don't care. They're there for you. So you can use the information that we're going to be discussing here with those key bitting specifications. The first and by far the easiest way to decode a key is to reference the direct code. Let's see if I can get this to focus. In this case, this is a Schlage C keyway key from Schlage, obviously. The bitting, or the direct code in this case, is 33785. And obviously this is a factory key, but aftermarket manufacturers utilize direct codes as well. Direct codes correspond with bottom pin links. So for example, if we were to pin this up, we would utilize the bottom pin links of 3, 3, 7, 8, and 5 from bow to tip. One exception to that, which might confuse you, because if you see something other than numbers, you might be wondering what's going on. A lot of the older Sargent utilize numbers and letters. In this case, it says NRG 547456. Let's ignore the N and just pay attention to the RG 547456 portion. RG in this case refers to the keyway. It's a Sargent RG key blank. So once we know that, we can ignore the alpha characters altogether and just focus on the numbers, which are 547456. And that, in this case, is the direct bitting for these keys. I don't think Sargent does that anymore. I know that they're putting their keyway in the top left of the bow and then just using the direct code in the form of numbers. Those are factory keys, cut keys, obviously. But it's just something to keep in mind, so if you run across it in the future, it doesn't confuse you. Another example of code would be blind codes. In this case, we have alphanumeric characters. We have EB020. Now, the way blind codes work is you reference a blind code against a code book or a code software. Code books still do exist. We use them in the shop. We've got quite a few of the older Reed volumes, but if you don't have access to that, you can always go with a code software, something like Instacode or Blackhawk. And the way it works is you input or reference that blind code against that source, which will in turn give you the direct code. So just something to keep in mind. Another thing too, blind codes can be numeric only, but they also can be alphanumeric. And when you're using alphanumeric, it's important to know that as it pertains to master key systems and the standard key coding system, you don't confuse key set marks from a master key system with an indirect code. While a large majority of indirect codes are only going to be found on cabinet and cam locks, which obviously are smaller compared to conventional keys, there are examples where a full-size key, for lack of better terms, would have that stamped on it. So it's important not to confuse the two. The best way to do that is to learn the standard key coding system, and there are books about master keying that can teach you that, and that's probably your best route. But I believe there might be some documents online specifically from Asa Abloy that will teach you that. But just something to keep in mind, don't confuse the two. If you see it, more than likely you won't. But examples do exist, so it's worth mentioning. Moving along the spectrum of key decoding options are key gauges. Manufacturers make these as well as aftermarket. I know ProLock makes ProLock might make this key gauge. If not, they make something very similar. This one actually has multiple decoding options: Quickset, Schlage, Weiser, Master, and Westlock. Here's one that was made by Sargent that covers their 20 thousandths key bitting specification. And then Yale, since they have two 19 thousandths and 25 thousandths, it covers both of those. And the way these work, and we'll use this one because it's got a Schlage cutout. There's a cutout portion along with index markers that correspond with the code. So the way it works is you insert your key in the widest portion and you try to center the cut into the index portion and slowly drag it along until it stops. We're stopped right here at 3, and obviously because we have the direct code we know that's true, but that's the way it works. You drag along until it stops, and that'll tell you your cuts, and then you just move along the key bow to tip until you have your full bitting or key combination. And there are some other ones. I don't know if they still make any of these anymore. This is an old one from Ilco for Lockwood, both sectional and regular key bitting specifications that contain not only the whole numbers that correspond with the key combination and the bottom pin links, but it also contains the measurements in thousandths of an inch. And here's another one that a few guys on ClearStar put together. It's kind of hard to see. A few years ago, but it covers Schlage, Quickset, Sargent, and A2 by Best, and contains the measurements again in thousandths of an inch. And we'll cover how to use those shortly, but first we'll talk about other devices that you can use to measure those thousandths of an inch, and those are calipers. In this example, these examples, I've got a digital and then a manual dial. Some people prefer either or. It doesn't matter, as long as they're calibrated correctly. You can get it done. Obviously, digital is going to give you a few more options. On this one, we can measure both in inches and millimeters. So it gives you a little bit more options. And obviously, reading the measurement on this, if I can get it to thousandths of an inch, it's going to be a lot faster than perhaps reading not only the dial on this one, but where you're at along the length of the caliper. So rather than looking at two numbers to get the measurement, on here it's instant. Now the way this works, to measure, you have to keep in mind one formula. That formula is effective plug diameter minus root depth will give you your bottom pin length. And all these figures are in the key bitting specifications I mentioned earlier, but I'll show you how to use this real quick. What we'll do is we'll zero this out. So to measure the root depth is the bottom of the cut to the bottom of the key blade. That amount of material is the root depth. So just like on a key gauge, we're going to center the calipers within that cut to measure that root depth. And we are just a little bit over 29 thousandths, 0.2910. The effective plug diameter for Schlage Classic is 0.500, or half an inch. So we take that 0.500 and subtract from it 0.2900. In this case, I'm cheating. I already know what it's going to be. So if we ignore the decimals for a moment and just subtract 500 or 290 from 500, 500 minus 290, we're going to get 0.210. Well, if you check against the key bitting specification, you'll see that a 0.210 pin is a number 3 cut or a number 3 bottom length depth. And of course, since we already know that, checks out. But basically, you go along each cut measuring. In this case, this is the 7th depth. If I get it centered, we're about 0.2310, so we'll just round down to 0.230. 500 minus 230 is 270, which is a 7th depth for the Schlage Classic key bitting specification. So that's what you can use these for. And in addition to measuring the root depth and the of the key, you can measure other things like pins, pin lengths. You can measure diameters for screws. You can measure parts, all kinds of things you can use these for. So they're multi-use, which I'm always about. And then I guess another example of these, or a measuring device itself, would be micrometers. The thing about micrometers is I don't know of anyone else other than HPC that makes them. And in order to be useful for decoding keys, you're going to need a very narrow and precise stylus, which is right here, to get inside those cuts to make the measurement. Now, if you're able to find something aftermarket that does that, great. But for the price that you're going to pay for a caliper, you're probably best served getting just a general purpose micrometer. Or I think I said that backwards. For the price you're going to pay for a micrometer, you're going to be better served getting calipers there. This is a general caliper, general sold through Home Depot. I think I paid $15 or $20 for this about 6 or 7 years ago. I haven't even had to change the battery, and it gets used at least once or twice a week. So it's long lasting and very accurate. And like I said, you can use it for other things, measuring pins, for example. And then the final example of decoding is visual decoding, which takes a little bit of experience and practice, but once you get it down, it's very reliable. And the way visual decoding works is you basically use nothing more than your eyes and your knowledge to determine what the cuts are. And down the road, we'll make an article about visual decoding, but basically it comes down to observing the positions of the cuts in relations to known quantities on the key. For example, the top of the key blade, or maybe its position in relation to a ward or a groove on the blank itself. But with time, you can get very proficient at it, and then it's almost as fast, if not faster, than reading the direct code itself. So those are just a few of the options available, probably the most widely known and used options to decode keys. One other option I'll show you, I don't like it, which is why I didn't include it in the article. If you have access to a plug that fits the keyway that you're trying to decode, in this case C, which is why it's marked, you can place the key in there and begin to take pin segments for bottom pins and kind of figure out where they relate to the shear line to determine the cuts. I don't like to do that. I think it takes too long, but that's there if you need to use it. But other than that, minus obviously the plug, which I don't like, those are your options as far as decoding keys.